Yeah, hello everyone. Very happy that so many of you actually sign up for this. So we hope that we can share something with you to benefit um, all of your needs lah. But I think we have seen some of your responses to our Google survey. Okay, we'll try to address most of them. Okay, we'll try to address most of them. So later during the Q&A, if you have there's certain things not being addressed, or you have a question that is burning, just please turn on your mic and ask. Okay, so let me just begin first. I'll just begin the sharing. Let me just turn on my screen. Okay, I think I need to share the screen with you guys. Okay. Okay, I hope you can see this. The slides. If you can't, just let me know. Okay. If you can see, just maybe one or two of you sound up so that I know that I'm not talking to the air. Yeah.
Can see, can see.
Okay, thanks. Yep. Okay. Just give me a while. Sorry. I think I received a text. Okay. Okay. Yep. Okay, just a short introduction to myself and Shuang Ning lah. We are both involved in the H3 NLC. So let me just go straight to this NLC milestone, just to share with you a little bit okay about where we are lah. I'm actually have been teaching in Hwa Chong since 2010. Most of you might have seen me before on and off. Okay, I've been teaching H3 since 2011. Was actually the coordinator for H3 in Hwa Chong. Until last year, actually passed the baton to my other teacher. Okay, but I'm still very actively involved in a lot of the work involved lah. Shuang Ning is in Dunman High since a couple of years ago. So she was also very active, and in fact, she's one of the first to actually come in with us to do the combined prelim lah. Okay, so she's actually the second in charge for our NLC. Okay, so in that case, currently for this year, she's actively doing the combined prelim part with the other partners. Okay, so just a little bit of our background in case you are wondering who we are, and then maybe along the way, if you have other questions, you can just let me know. Okay, so I'll just go back to this. Yeah, we will have a break at about 3:45 to about 4ish, thereabouts. But we also put it as a Q&A lah, so that we don't waste precious time. Okay, then from 4 o'clock onwards, Shuang Ning will take over. Of course, I will along the way I will give a bit of comments here and there, because because the bulk of the thing that we wanted to share with you guys is actually how could two schools come together, right, to actually conceptualize a stimulus-based question. Actually, you'll be surprised, because this stimulus-based question actually was a combined effort from two schools. Although on paper meaning in the TOS lah, it's actually set by Shuang Ning, but I think a lot of it there were a lot of ding dongs along the way when we are discussing what exactly is going on and what should be in, what should be out, and then all this whatnots we'll share a lot later on at about 4 o'clock. But before that, I just want to bring you through some largely is some stories and maybe some things that you really have in your mind, like what exactly stimulus-based question is, the specimen paper. I want to know a little bit more about the A levels. Okay, so those questions will be answered, but they are being answered based on my perspective lah. Okay, I have to share this with you. This perspective is definitely not SEAB's perspective. is of course it doesn't represent CPDD perspective as well, because a lot of it has got to do with what I feel the other party in Cambridge is thinking about. Okay, so yeah, so normally I think this is an important slide that we need to share with you. Like, all the opinions are solely, at least for this section, they are solely my opinion. So if there's anything that you don't agree on, etc., it's just me. Okay, you want to ask things, just ask me about it. You don't agree, yeah, it's me. So it has nothing got to do with Cambridge. It has nothing got to do with Hwa Chong also. It has also nothing got to do with Shuang Ning, etc. Okay, so just to let you know, because we all have different thought processes or different viewpoints when we come to looking at stimulus-based questions. Okay, yeah. But before I move on to what I really wanted to share with you on the stories, right? I thought that I just want to share with you a little bit about the milestone of the NLC. Okay, so this NLC was started in 2017 because there's a need to for people to come together to actually narrow the gap between the schools in order for them to prepare for the revised curriculum in 2019. I guess a lot of you are aware of that. So it has to be started like 2 years before, so it's 2017 because that a lot of groundwork needs to be done. Okay, so but of course 2017 we do it really slow. Then 2018 the momentum increased a little bit. 2018 was the last year of the pharmaceutical chemistry syllabus. So because it's the last year, it's the final year, and that batch of students, at least in Hwa Chong, right, they are pretty decent, pretty strong, I think fairly decent. So we could test bait a few things lah. So one of the things we did was we actually try out a stimulus-based question with this batch of pharmaceutical chem question. Yeah, well, students, because we feel that in terms of resource developing, right, you have to start ahead. You cannot develop the resource as you go ahead, because that will mean that a lot of things will not be done properly, or you'll be out in a rush. So that's our belief lah. Okay, and of course I was speaking to Shuang Ning 2 years ago. I said, hey, shall we do a combined prelim lah? I mean, let's test bait something and we see how it goes. And again, last batch of pharmaceutical chem students, pretty exciting batch, not that weak, quite strong, etc., right? So in that sense, I think the combined prelim, we just want to see how it goes lah. So yep, 2018 we did that, and then with all the learning we had, 2019 first batch of revised curriculum, so there's a lot greater collaboration between a lot of the schools. I wouldn't go into details, and then again, more stimulus-based question was done in Hwa Chong, and then after that we have a combined prelim last year with 4 different schools. Okay, yeah. So if you're interested to know any of the work we are doing, just feel free to write to me or Shuang Ning. Okay, so I just want to share a little bit with you regarding my personal philosophy. Some of you might have heard of it, because personally I believe that our job as a teacher is to stretch students. So again, it has to come from the way we not only we teach, but also in the way we formatively assess them. Okay, so I always believe that the questions has to be forward-looking, and that's why stimulus-based question is always a good way to go. And I guess you have realized from the new revised curriculum for both H2 and H3. In H2, it's called database questions, that a lot of these were unseen. So we call them pretty forward-looking question, pretty contemporary chemistry ideas being tested. Okay, so when we try to implement it even in our own school, right, I think being forward-looking is also very important, rather than the students being shocked in the actual exam, right? We expose them early lah. Okay, so of course at the end of the day, my philosophy would be to challenge the writers even in the question. Okay, but for the weaker students, they do not feel so demoralized that they just want to give up, because hopefully you inspire them to become more interested in the subject disciplines. Okay, yeah. So I'm just going to share with you something really exciting, because normally this should or could be done at the end of the session, but I thought I'd just bring it forward. Yeah, because it's something very, very real, and it's fresh from not exactly fresh from the oven, but it's something that I experienced it like less than a month ago. Okay, yeah, so I just want to share with you guys a little bit. Don't worry. If in case you are thinking, am I sharing some holiday stories with you, or some totally unrelated stories? No, it's totally related to stimulus-based questions. Okay, I can assure you, you will have some takeaway, but some might have a lot, some maybe not so much. Okay, so bear with me, just bear with me, and if you have things that you want to comment later on at 3:45, you can always let me know. Okay, so okay, just just something very quick. I had the privilege to be away from school for 2 weeks. Sometime towards the before the March holidays, actually. Yeah, like a week before. Okay, I know it's not the correct time to be away, but this thing has been planned quite some time ago, and during that period of time there's no travel ban, so everything was still okay. Yeah, so yeah, I actually went to La Trobe to do a sabbatical. So what exactly did I do? Okay, basically I went there to teach. Okay, La Trobe is actually a university in Melbourne, for some of you who are not aware. So I actually teach a course called photochemistry. It's a year 4 course over there. And I managed to teach the whole course myself. So during that 2 weeks, they just packed the curriculum into a couple of lessons, so I teach the whole course by myself. Of course, there are other things I've done, but I will not go into details. But the main thing is we need to be a bit more targeted for this workshop lah. So there are a lot of other things, but I think I want to be more targeted. So basically, at the end of the day, I need to set a question for photochemistry. Okay, I mean that's a short story lah. Okay, so I need to set a question. So because I thought that this sharing is really timely, because a lot of my colleagues, even amongst you lah, or even acquaintances from other schools, always say, so how do you actually go about doing database? How are you going go about setting a question on stimulus base? Because it just seems so difficult. Where do you get your ideas from? Which is exactly what a lot of you mentioned in your survey. So where do you get your ideas from? How do you actually formulate? How do you actually add the different layers of thinking, etc.? But the truth is always there's no easy solution to that. So I always thought that if I share a story, it might be easier lah. Okay, so again, what should I do? So my best friend, our best friend now is always Google. Okay, so so I will just change screen. I'll straight go into Google, because I think going into Google is easier. Okay, I'll just go into Google now. Oops, I think there's some. Oh yes, yeah, yes. We'll send you the slides. Don't worry. Yeah, I think sorry, a teacher actually texted me saying that he can't come in. Sorry, so if you can give me a minute to reply the teacher. Yeah, very sorry. Because just now I was talking, so I cannot reply you. Just let me just click. I just want to find just give me sorry, just give me half a minute. Okay, I will just go straight. Okay, so okay, again, if you realize that I'm talking and then you're not saying anything, just sound to me. Okay, so okay, okay, I just give you a bit of context lah. I mean, La Trobe is a university, so I'm in a university setting. I have a small desk on my own, and then nothing else. After I teach the course, what should I do, etc. Right? So I need to set an exam. Google is always your best friend to begin with lah. Okay, the reason is very simple. Unless you are in an area actively in research for the past 1 or 2 years, right? If not, you wouldn't know who are your competitors lah, or you wouldn't know like who are the top research groups in this area. So I think if you go into Google, is always the best way out. That's why the Googling part is important. And then some of you might ask, why photochem? Okay, because photochem is a course I taught I'm teaching the student. So that's why it makes life a little bit easier, because in terms of the themes, okay, in terms of the themes, it's already compartmentalized for you. So the themes is already compartmentalized. So a lot of things are a lot easier. Okay, but of course, Shuang Ning and I will address a little bit. I mean, there's no answer to that, but we'll address a little bit to questions like, how do we go and find a theme, etc. lah. Because themes, all this, finding themes, it's always something that you could start doing from now. Like you start to, as you walk around or as you read stuff, you look at themes here and there, and then maybe carbon, CO2 recycling interests you, so you can just gather some resources and put it somewhere, and then when you need it, you can just find them. Okay, so again, so what I did that day in a lazy afternoon was I just typed photochemistry research groups. Okay, we all have, I mean, at least I have to admit that definitely you start with Google, or even in the past is Yahoo lah. Then of course, normally human instinct, you click the first thing that comes to your mind lah. So which is exactly what I did lah when I was there. Yeah, because it happened less than 2 months ago, right? It's very fresh in my mind. That's why I can tell you exactly what happened. So yes, I went to this group, Fuster group. Okay. So to cut the story short, so normally, right, once you have a theme, right, it's always good for you to maybe save some of the research group favorite into your favorites, into our browser's favorite. It's good to save them so that when you want to refer to them, it's easier. Okay, but I can tell you that out of 100 things you save, maybe only 10 is useful for you, and eventually only 1 make it to the question. That's reality. Okay, yeah. So this Fuster group, so that day I browsed through. So I'm just fast forwarding a lot of things lah. Okay, because all these things takes a couple of hours, in fact a few days. Okay, so yeah, so I saw this. Wow, so very nice, photochemistry. So this is one of his area of research, and then he has some beautiful works like novel organic photo switches, and then photo switch using lights, because I teach photochem, so there are some areas that we are I know the student roughly can get or cannot get lah. And then CBL is too much for them, because I don't know whether this batch of the honor students over there understand what exactly is circularly polarized lights. Okay, so I will skip that. Yeah, so normally after you have done all this, what will you do? You just because it's in a university setting, right? So you can just click. Okay, so let me try for this. You can just click on the DOI, and then after that they will send you straight to the research journal. I know that a lot of your in fact all of us, right, we don't have access to all this, which is also the question that a lot of you are asking. Okay, but what I can share with you now, and I realize, is that during this period of COVID-19, right, actually a lot of the research journals, right, they offer you for free. Actually, I also don't know why. Yeah, I know it's only the research on COVID for free, but some of them actually you can access some more recent articles. Okay, so I think make use of these good opportunities at home to do searches. Yeah. So okay. So anyway, so what exactly happened on that lazy afternoon was I clicked on a lot of this link. I searched for a lot of things, and then I'm just going to show you directly what I have. Okay. So these are the articles I downloaded over a couple of days lah. In fact, it's a lot more than this. Okay, you can easily, like, about 15 to 20. It's actually a lot more than this. But some I didn't even bother to save them, because I know that they are not very useful lah. Okay. So okay. Some of you might ask, downloading come first or look through them first? I would say you look through them first, but some might be useful for you in the future. Okay, so photo switches seems to be quite good, quite inspiring lah. Because when I look at photo switches, I thought that, okay, I don't have to look further. I will just straight away use those resources. But you know that after I looked through the article, I was quite disappointed, because when I opened the photo switches, right? Okay, so now I hope that those of you who asked a question along the way, that how do you know if something is suitable or not, right? Whether is it a website, an abstract, or what, right? Sometimes when you read through it, you will know whether is it suitable. Okay, so these photo switches, when I read through, right, um to be honest, there isn't much I can ask lah. That's a very short question I can answer you. Okay, because when I started, when I wanted to set a photo chem question for the honor students, right, I wanted to do it stimulus based style. So I wanted to give them an abstract for them to, you know, compare and contrast, very similar to the specimen paper question. So I'm looking very hard at all these lah. But when I look at their work, it's not that it's poor work or what. It's actually great work. But I realize I cannot tweak it to the way I want. You know, the compare and contrast type of setting you have. Like maybe at one moment you use Haber-Bosch process. That's for last year's paper. And then after that, the author came out with a lithium electrocyclization process. You guys get what I mean, right? Like normally data stimulus based question has that kind of flavor in it. Like there's something contrasting, so that the students will be put in a state of mind where they are able to do some critique. Of course, it's not being asked, but something for them to think about lah. So when I look at this material, it's very good maybe for a structure or free response question. Maybe. Okay, I'm not saying it's not, but I just find it difficult to do that kind of compare and contrast lah. Okay. So normally I think in life, number one is if you feel that cannot, you just have to move on lah. Okay, so I look at another of his article. It's the same research group, Fuster research group. This is a much longer version, but again, when I look at it, it looks interesting, but it's not very inspiring lah. Like you can't really frame a story out. You can't really formulate a story because there are just a lot of data is focusing on one area of research, which sometimes is very difficult to formulate a story. And I can tell you that it is also dependent on how good the authors are in drafting their research work. Because if they are not very good at writing out their work, sometimes on our end it's even harder to do anything. Okay, of course the data are good. I mean, you can always use a free response. Okay, so yeah. So after I read all this, then I feel I'm sure a lot of you will feel the same way. Because some of you might have been through this lah. You'll feel a bit shitty, and then you say, okay, you have just wasted half an hour of your life looking through stuff that you can't use for setting, but never mind, let's move on, kind of idea lah. So yeah, so that's what I did lah. So I move on. I went on to, you know, download a lot of the article, and then you just have to this is another work by Fuster. So so what I did was I read through them, etc. I mean a lot of data, but you can't formulate a story. So I was a bit disappointed. So again, I went back to Google. I went back to the Google page. And then so okay, I tell you what happened over that 2 or 3 days lah. I just click lah. Just click all the link lah. But I'm quite fortunate that day because I clicked on the right link lah. Yeah, I clicked on this research group by Korean American research. He is beautiful in writing stories. This guy, like Professor Yoon. Yeah. So if you click on Yoon's research group, you know, I think number one is, I think from the website you really know that he's very beautiful at he's very good at, you know, crafting stories, because you can see that his ideas are all very simply put. See, like that, very nice. Okay, so he put it in such a nice way, and then I say, oh right, yeah, I remember this because I taught the students this. I hope now you can see the link lah. So whenever you go to a research group, you saw something, maybe in nucleophilic substitution you have taught the students about, or transition metal complexes, you know, then you can just stick out, and then maybe you can use them in the future. You never know. Okay, so anyway, cut the story short again. So when I looked through this, I thought I'm quite inspired, and he did beautiful work. So the whole process is repeated lah. You just download his articles, and then you read through, etc. So so what I did was I downloaded his article, I read through, and then in the end I streamlined into 2. Okay, I finally decided into 2. So and of course, if you heard me just now lah, why these 2 articles, right? Is for a very simple reason. Because those 2 work are quite different. Yeah, and it's done by the same person, which is easier lah. Okay, so so this piece of work comes later. It's called triplet energy transfer. Okay, instead of the normal one where the electronic state are the one that actually transfer the energy for the system to take place, but in this case it's actually through the triplet state lah. Okay, so you can see that you can also appreciate how good the writers are writing stories lah. Okay, so first they give you a very nice background, and then after that their diagram is very sleek and clean lah. That's what I like lah. And then after that they are very nicely presented. So these are the kind of work or websites lah, or abstract that you want to take, okay, that you potentially can use. Okay, so yep, so I chose this. Okay, then after that I also chose the other work of theirs, which is actually earlier in 2014. Okay, so this is not using triplet transfer. Okay, it's the normal one where they activate it and then they collide and then they activate this reactant, and then electron gets transferred, and then after that, tada, reaction takes place. Okay, etc. etc. So what happened was I was quite happy, but of course I read quite a bit of this guy's work lah. Even his review, just browsed through them, and then I sort of streamlined to these two. And of course, I have to tell you the truth. The deadline is coming lah, right? Yeah, I mean because I'm a those of you who know me knows I'm actually quite a perfectionist lah. So before I can set the perfect paper, I must ensure that the information is all there, and then I will keep thinking about it. But in reality that's not the case, because there's always a deadline and the students are going to sit for exams. You cannot keep delaying until until forever. Just like if you are tasked to stat stimulus based question, right, you just have to compromise somewhere. Yeah, so this is the compromise I have, which is these two paper lah. I actually had something a little bit better in mind, but I can't fulfill that. Yeah, so in the end, yeah, so to cut the story short, this is the final exam of the papers I set. Yeah, because it's actually between me over there and then Latrobe. So yeah, yes, two of this. It's exactly the same. Yeah. Okay, this is actually the question. So the question is very short. It's only 2 pages. Very, very similar to the stimulus-based kind of question that you expect your students to have. And then in case you are wondering how the insert look like, right? It looks like this lah. The insert is a bit long, but please take into consideration that these are university students. Okay, so what I did was I tried to cut down the words. Okay, but I gave a lot of diagrams. So eventually the question looks something like this. Okay, I try to have a lot of tables to ask the students to talk about all the nitty-gritties, etc. So yep, so this is exactly what's happening when I actually set this exams lah. So there are a lot of things that goes through my mind, which of course I definitely cannot convey within this short period of time, but I hope that it's clear enough, like what exactly is happening. But of course, I'm sure there are things that I wanted to say, but I didn't manage to say it. So if Q&A you guys manage to ask it, then that'll be good, and I can talk about it more. Okay, so in the end, I thought that if you want me to sum up some of the ideas you have to take away, so I will have the first bullet point will be, please start gathering stuff whenever you have some time now, which now I think the COVID-19 period we have a little bit more time. I'm not saying we have more time, but a little bit more time than you expect. So yep, please start to gather materials, and then have a sense of the themes, meaning well, I mean, so we are all from a slightly different background when it comes to chemistry. You have a favorite ABC, I have my favorite XYZ. Okay, I would say explore beyond ABC and or even my own XYZ, and then you realize you learn something new, and then it can be easily crafted into some questions, and then gather all the information. It will be good to read more lah. Okay, because without reading more, you wouldn't have that context in at the back of your mind. Practice here doesn't mean do the question. Practice here means practice setting. Yeah. Okay. So we can share this more later, but it's not the theme of our workshop lah. Because this particular sharing or workshop is more on talking about the stimulus based question setting rather than what exactly is happening within a school's running lah. Okay. But when I mean practice here, I can add one point lah. It will be more of rotate the people to set stimulus based questions, and then of course at the same time where possible, right, expose the students to at least twice in 1 year lah, one prelim and one non-prelim. Yeah. And then the non-prelim one you get another person to set lah. I think practice will make yourself a little bit better. Okay, the last point I always remind myself as well, you need to balance between reality and ideality. Okay, I think I've mentioned it quite a bit just now. Okay, so as promised, and as per what we normally we want to share with the participants, right? Let's take a closer look at the stimulus-based question of the specimen paper and then the 2019 paper as well. Okay. Can we also remind ourselves one important thing? I think most of you will have taught history somewhere in your journey, and you might want to be reminded that the difference between this current syllabus and the old farm chem, right, is that the A to B ratio, right, is now tilted drastically to the B side. Okay, it's now 75% to 25% instead of 40-60. Okay, and if you are wondering why, I can tell you, or you can guess it lah. The stimulus-based question is the culprits. Okay, because stimulus-based questions, a lot of it is applications. In fact, all is applications. Yep. Okay, I'm just okay. I'm not okay. My role here, or rather our role here, is not really to explain this bit by bit lah, but it's just to try to also tell you what I think is the thinking behind the examiners, okay, when they are setting this. Okay, so if you look at the specimen paper, right, which I assume that you will have access to it either now or even in school, right, is that for abstract 1, they used an abstract from ACS, Journal of American Chemical Society. Okay, and then they have a figure there, okay, which is figure 1.1. Okay, if they ring a bell, then which means you have seen the specimen paper quite a few times. Okay, and then they give you some data, which are the energetics data over here. Okay, now if you have access to the ACS website, which you can easily access it, but you can't download the paper. Okay, but I have made available the actual research papers in the folder, so if you want, you can go and take a look. Okay, but if you just want the abstract alone, right? Yes, just go to the website. Anyone can have access to the abstract. You realize that actually the abstract and the one that the specimen paper give, right, it's actually exactly the same. It's exactly the same. The only difference is maybe they call this A and B, and then for the other one, they call it something else which I can't remember lah. Yeah, anyway, it doesn't matter. Yeah, they call it just just the full name, etc. Okay, so if other than that, they didn't modify a lot of stuff. Okay, and then if you look at this scheme, right, they actually didn't modify much things. Actually, everything is as it is lah. Okay, so yeah, just keep that keep this idea at the back of your mind. And then if you look at abstract 2, it's the same thing. They just copy the whole thing from the science paper. Okay, but of course, for this particular diagram, it's heavily modified from the actual ones. Okay, let me show you the actual one. Okay, so this is the actual science paper. You can see that everything is the same. Okay, just you can do a bit of compare and contrast. Yeah, everything is about the same, even if you just count the number of words lah. Okay, but the diagram is a lot tougher. Okay, so what Cambridge did was, if the diagram is very cluttered or too much for the students, then they will modify it to become something simpler like this. In fact, actually there's something going on, but they just remove it lah. Okay, because they probably realize that it's not going to be very useful. Okay, I'm not going to go into the question, of course, yeah, because and then now I'm going to go straight into the 2019 paper lah. Okay, so if you look at 2018, right? Not 2018, the specimen paper, right? I guess back then when it was released to the teachers, I think quite a lot of people actually commented that the difficulty level is too much. So I guess Cambridge, SAB took the comment, and then Cambridge might have taken a look at it lah. So you realize that 2019 the paper is actually the abstract is a lot shorter. So basically they just took one from Chemistry World. Okay. Okay. Can I also make one mention here in case I forget to talk about it later lah? Chemistry World is sort of free, so you guys just need to go there and register an account using your school email. It's actually free, so once you register, you can read the article. So they have this kind of article. So this whole chunk is taken from Chemistry World. Yeah, can you see? I've also uploaded the PDF version of the article into the shared folder I sent to you earlier on. So this is Chemistry World. So if you look at everything, it's actually the same. In fact, they have taken everything in except that they made a word simpler. I can't remember. Okay. So can you see here? Electrochemistry has long been mooted. So I think they are afraid that the students don't understand what the word mooted means lah. So they actually took out the word. Electrochemistry has long been I don't know why they go and put a bracket here. And I think they can just put mooted lah. But they are just afraid that maybe students don't understand the word mooted. So they put brackets suggested. Okay, anyway. So they have taken everything wholesale except the more difficult English words, perceived more difficult English words, they took out and then just leave it. Other than that, they took everything from chemistry world. Actually, the abstract is everything from chemistry world, not from fanciful journals. Okay, just to let you know. And then the ideas. Of course, I also want to make one mention here. If you can remember it somewhere, just jot it down. Actually, this chemistry world, right? The article is actually what I term as a teaser to the actual research paper. So this is actually the actual research paper. Okay. Actually, what you might be wondering, what are teasers? Okay, teaser is a term I came out with, but I don't know the actual term that people use. So basically, it's a bit like an advertisement lah. So for example, maybe chemistry world, the editor have read, maybe some of the authors have read quite a number of interesting research papers, and then they decide that, okay, because I need to submit something to my editorial, right? So let me just briefly write about some interesting article I've read. So normally they will condense it into something very simplified, just like Scientific American. So we call it teasers lah. I call that teasers. So and I realized that actually chemistry world, the reason why it's good is because a lot of the articles over there, right, they actually are sort of a simplified form, or the simplified summarized form of an actual research paper, which you need not have access to it, but you can always use the teaser to set something. Okay, so in this case the teaser was used to set something, but you realize that a lot of the data you can get them online as well. Okay, but anyway, for this, in the case of this, they actually get from the this particular paper, and then they have a lot of information there. In case you're interested in this paper, no problem, I've also uploaded for you, so you can just go and look at it. So once you look at it, then you realize that actually there's some form of contrast, okay, between the teaser and the actual paper. And then at the end of the day, if you go back, even for yourself or even for the teachers in your school, right, you can always share with them along the way that work with something that maybe you're more comfortable with first. Maybe just go subscribe to Chemistry World, or some of the free, there's quite a number of free journals actually. Okay, and once you do that, then start to gather resources, or even get some textbooks if you want. I think yesterday my friend sent me a list of textbooks that you can download for free. Wow, okay, from Sprinkle. Okay, so I think this is a good time for you to gather resources. Okay, so anyway, this is a summarized form of the comments that I thought I want to make regarding the specimen paper and the 2019 paper lah. Okay, so the first point I want to make is that they usually the ideas that they want to expose students to are usually contemporary areas of chemistry research lah. Contemporary meaning new areas. Okay, and then the second bullet point I want to mention would be usually there's a contrast, okay, between the two abstracts. But for last year there's no two abstract lah. Okay, but actually there is a hidden first abstract. The hidden one is the Haber-Bosch process. But it was not mentioned. Okay, and then the third bullet point, I think you can see unknown terms will either explain, that's in a specimen paper, or replaced. The term will be mooted. But here I mean more chemistry term not really English term. But I realized last year they are quite kind with the English terms. Okay, and usually some additional energetics data are given, because energetic calculation proved to be quite popular for H3. I also don't know why. Easy to ask maybe. Okay. Fifth and sixth bullet point is in black and blue. Okay, black will be for specimen paper, blue will be for the 2019 paper lah. I just color code them. Okay, open-ended parts, I've listed them. For the last bullet point, integration of topics, more concept is very popular. Organic chem and then energetics will be specimen. Actually, it's more of energetics and more concept. Very little bit on organic chem. Okay. For last year, more concept, electrochem and energetics. Okay. Yeah. So that's the little bit of things that I thought I want to share with you at this stage. And of course, I want to bore you with this practices of science, but normally you realize that when they set the question, they are focusing on a few areas. For example, interpreting data 2.4, and then making decision and doing evaluation, what we call the open-ended parts lah. That's 2.7. And then for relating science and society, usually 3.3 lah. Okay, use scientific principles, reasoning, understand, analyze the real world system situation. A lot more. I realized this was shown a lot more in the specimen paper rather than last year's paper. Okay, so we don't know what to expect for this year, but anyway, we'll just continue to expose our students to interesting chemistry, and I'm sure you will as well. Okay, I have also uploaded this article for you guys to read, charting a course for chemistry. Okay, so in this particular, okay, this is not a research paper. This is basically interviews with I think hundreds. I can't remember how many 50 or 100 contemporary chemists, and for them to talk about what they think is the in thing now lah. Okay, so you realize that this particular chemist, if you read what she wrote, she wrote blah blah, and then sustainable production of chemicals and fuels from the reduction of water, nitrogen, and carbon dioxide, or carbon dioxide. So you realize that actually okay, because some of you will be thinking, what are the themes? Because themes like what photochemistry, transition metal, very broad. Can I narrow? Can. Read this article. Okay, if you read this article, then look at what everybody is saying, take down some of those that you're interested in, and then just look at those themes, and then you have a feel for the next few years. That's what I feel lah. Okay, so yeah, but of course there's a don't assume that everything will be good lah. Yeah, because maybe you like this person's work, and then but when you open up, you realize a lot of it not very relevant. Yeah, it always happened this way. But then not very relevant, but somehow it might be linked up to someone else's work that is super relevant. Okay, it always works that way. Okay, I want to introduce you all to Google Scholar. Okay, if you have done it, you might know what it is, but I just thought that a very quick introduction helps. Okay, so if you go to Google, you can just type Google Scholar. Okay, Google Scholar actually contains link to a lot of research articles lah. If you're wondering what this is another database that you can use lah. Okay, so I usually like to go to advanced search. Okay, so for example, if you try to type converting carbon dioxide into feedstock, which is the theme for 2013. Okay, converting carbon dioxide into feedstock. Okay, and then maybe you can put carbon dioxide as the main thing that you really want to talk about. I mean, you really want somewhere, and then I think you need to narrow down your years. Usually we want contemporary years. So 26, I purposely clicked 2016 because 2016, because Cambridge sent the specimen paper in 2017, right? So I suppose whatever they have done must be related to 2016. So true enough, if you just go do a quick search, right, you realize that if you just scroll down very quickly, don't know whether I'll miss it lah, but you realize that the two of the top articles can be easily found. Okay, I mean I'm not exactly focusing a lot on the search lah, but if you just scroll down, you realize a lot of methanol kind, and then electrochemistry, then carbon dioxide to methanol, you see. Okay, so I did a search earlier on over here, so you can see that sorry. okay, I did a search earlier on, then you can see that this article was actually found I think on the 4th or 5th page. Yeah. So so I think my point is at the end of the day, this is one of the tools you can use to help you do some searches for articles if you feel there's a need to lah. But I always feel that looking at themes and research and a particular one or two research groups and subscribing to Chemistry World will be more than enough for most people. Yep. So this is what I can sum up for Cambridge. Maybe I'm not their spokesman, but if I'm them, this is what I will be thinking. I need to look at the contemporary era research. For the specimen paper, it will be CO2 activation, and then last year will be nitrogen activation, and then gather articles, and then after that different methods, contrasting examples. So for specimen will be enzymes versus non-enzymes. Last year will be Haber-Bosch versus electrochemical lithium cyclization. Okay, and then different outcomes. Okay, so specimen will be you are getting methanol in one of the ways, and then after that water and H2O2 in the other method. Okay, then for last year one, I can't really think of it, but I would say is small scale versus large scale, because if you read hard enough into the work, you realize that the electrochemical lithium cycling, as good as it sounds, you can't do it big scale. So I would say yes, although it's fantastic work, but you can't, it's difficult to let it run in a bigger scale lah. Okay, and then yeah, briefly read and check its relevance lah. Okay, so it's pretty much the same thing that as I mentioned earlier on. Okay, I think I will skip this because I think I'm running short of time, because if not we will overrun this session, and then after that there won't be enough time for you to hear the main thing, because actually this part of the segment I just want to share with you a little bit of our journey over in Hwa Chong, particularly those parts I'm involved in actually setting stimulus-based related questions since 2012. Actually, our journey started way earlier, since 2012, but the bits and pieces. So if I have time later, I can talk about it, okay? If not, then we will just skip this, because it's really not super crucial. Okay, so as if I go back to our outline for today, right? Okay, we are running a bit short, but yes, now it's actually the Q&A for part 1. Is there something that you guys want to ask at this stage? If you want, just turn on your mic and then identify yourself, maybe, so that I at least I know who is asking question, and then I think Shuang Ning and I lah, okay, we'll try to answer it, or any one of you, if you have ideas, you can answer it as well. Okay, yeah, good. Yeah, I hope you are still there and you're not bored by what I've just mentioned. Okay, yeah, before Shuang Ning begins, right, regarding last year's stimulus-based questions, I need to give you all a context again. Yeah, because a context is always very important. Like because to begin with, a lot of you will be wondering, right, how did the question come about? How did the themes come about? Okay, so so I'm gonna give you the context, and then I'll pass to Shuang Ning. Okay, so so this is the context. okay, so the story is like this. The prelim was on 26 September. Then we need to wait, sorry, just let me take a look. Okay, sorry, just a little bit of hiccups. Okay, I think you can see it now. Okay, so this is the context. Okay, so I mean, the bad thing about this online thing is I don't get to see people's expression because I always wonder how will you react when you look at this photo. There's a photo in front of you. If you don't see a photo, just sound out, which means I'm not sharing my screen, okay? Yeah, but if you have seen a photo, then okay. Yeah. So what exactly is happening was that our prelim was 26 September, so we need to decide on the theme of the stimulus based question. The reason was because based on how we work, the stimulus base must come first before the rest of the learning objective comes. Okay, yeah, so the person can have all the free play in deciding what he or she wants to do, etc. Okay, and I left for holiday quite early. Okay, so I went to my first stage, my back then last year, not recently. Okay, last June. Okay, there's no COVID last year. Okay, uh Helsinki, my first stop was in Helsinki, so this is a BK in Helsinki. What am I doing in BK? I also don't know why, because it's a lot of space for me to sit around while waiting for our Airbnb accommodation to be available, because we were a bit early, overnight flight. Okay, so we have to spend like two hours extras. So I was sitting there, and then I can't remember that Shuang Ning was asked. She was texting me lah. She was still in Singapore. Okay, she was saying hey, so what's the theme? What's the theme is going to be? Then I suddenly remember, oh yeah, I haven't like created something. So I was thinking, oh, what should I do? So in the panicky mode, I was thinking if there's a Wi-Fi. Okay, so there's Wi-Fi and I have 2 hours to spare. Yes, so I was looking for some information online while I'm there, and then look through my very old folders on potential stuff that I can pass to her as well, because I mean how we work is, of course, we don't dictate what the person do. So I sort of gave her a few themes lah, like um nitrogen activation came to my mind. Okay, it's not a fluke. Okay, I know last year's A level was nitrogen activation, but back then I already have this gut feel that it's something I want to set. I'm not saying it will come out. I'm just saying that it's something I want to set if I'm the one setting, but of course I'm not the one setting. So yeah, nitrogen activation was one of the themes I gave her. I think there are some other themes like supramolecular chemistry, electrochem, particularly fuel cells, etc. lah. So there were a few. So it was in the Google folder I shared with her. The beauty of internet lah, like even we are like more than 10,000 miles apart, but we can still do this kind of sharing over Google. Okay, so anyway, I shared the stuff with her. So after I shared with her, I didn't know she went on her holiday, so she also went to Europe. Okay, so now I will pass the time to her to let her finish the story. Okay, Shuang Ning, it's your turn.
The story goes that I hope
okay.
you can hear me. I think my mic is on.
Okay.
All right. So the rest
Yes,
of the
yes.
story was I was also away, but I printed out other articles out before I flew off, and I spent most of my commute time on trains and buses and planes reading the articles, trying to work out what's going on. But part of this sharing, some thanks to those of you who have responded to our survey. So many of you responded. The people who said you have set the SBQ is like this very sad one person here out of 17 of you who responded. So part of this, the purpose of doing this is so that we can share our experience. You can learn from what worked and what didn't work for us, and just take it from there to see what could work for you if you had to set one SBQ. So because Chongqing sent me a bunch of articles, more than 10, I printed a bunch out, and when I was reading it, so my thought process about thinking what makes a suitable article for me is first, I must be able to understand it. So having been away from undergrad chemistry for a while, I needed an article that was a little bit more accessible. Then when I was reading through the articles, I would look out to see whether I could spot bits where H2 Chem could be related to any part of the article that was related to H2 chemistry. Anything that was related to H3 content I felt was a bonus, because from the specimen paper, that SPQ didn't actually require H3 content. There was no H3LOs in the specimen SBQ. And in last year's A-level paper, there was also no H3 content. So I felt having H3LOs from the article itself was not compulsory, but it's a nice thing to have. It opens the playpen a bit bigger, but I don't necessarily need to look. Then the other thing also to me was what kind of data did I want to use. So some of the data that I was looking out for was, let's say, any information about yield, reaction, and conditions, because using information about yield, hours, and things like that, I could make them perform certain stoichiometric calculations. Then in terms of reaction and conditions, that would be the setup of the question that would tell me, give me some information or some context for me to test the students, for them to compare maybe two different methods. Which one is more useful, which one requires more energy, which one maybe produces more harmful side products. Then having a catalytic cycle for one of the articles was useful because the specimen question did have a catalytic cycle, so I could mirror my question to that. Then synthetic scheme would be in terms of what are the reagent conditions, what are the intermediates. So if there's extra explanation, I could also pick out information in terms of type of reaction, redox, whether it's a nucleophile, an electrophile, and things like that. Then if it's a synthetic paper, they often would be characterization data because analytical techniques are in H3LO. So I could also potentially tap on that information, which is present in many articles. So these are at the back of my mind. The most useful article is actually this one. It is what in Zhongxun's language is called a teaser. It's a one-page review of a paper that's in Science. It's meant to, I think, hype up the paper. The actual paper itself is about 4 or 5 pages long, but this review article is only 1 page long. And it's very, very readable because it is so short. And very helpfully, it has also given me the contrast because this review article shows 2 methods. This particular article is useful because it started off by saying, oh, it talks about Haber-Bosch process and introduction. And that will then allow me to potentially link to H2 chemistry, what they learn in Chem equilibrium. Then they talk something about d orbitals using transition metal catalysts, which if I wanted to, I could test H2LOs on transition elements. Then there's other information in highlights, which is talking about the bond order, back donation, bonding and anti-bonding orbitals, which is in H3. It's a H3LO, so if I wanted to, I could also test those topics. So as I'm reading the article, I'm highlighting certain points and annotating and working out which are potential questions already. So this diagram is also in the article. It is very pretty diagram. And that was one thing that struck out to me, and I wanted to test this one. It shows, this article summarizes 2 different methods. One is the old method using transition metal complex that's on the left-hand side. And the newer method that's just published is the one using boron. So finding those end up being, at the end of the day, those ended up being the articles that I selected to use for the abstracts. So the abstract was one of the articles was the transition metal paper, and the other one was about boron. So the teaser paper itself, the 1-page article, has already given me the contrasts that would have been useful for the students to compare. Again, taking a look at the first paper, this is a bit old, but going through it, again, I'll highlight information which I think is useful. So the ones highlighted in blue, for example, it has certain information about yield, how long you need to react for, and that eventually led on to a calculation, a stoichiometric question. Then it also gives information about conditions. I can compare, okay, 55 degrees for 24 hours, under 1 atm hydrogen, is it better, more energy intensive, or more dangerous compared to the other one? And what kind of product does it yield? So I think this one gives ammonia, whereas the other paper, they actually give a variety of different nitrogen products. Then other information in this paper that's useful, they also make a bit of mention about how this reaction could possibly go. It talks about that ruthenium complex being I think it's an acid that provides the hydrogen, and there's a nucleophilic attack on the nitrogen from the other coordinate, from the other complex, from the tungsten complex. So within the paper, I could mine out certain information about how this reaction could possibly have happened. Then this paper was also very useful. It had a catalytic cycle. So once I saw the catalytic cycle, I was quite set on having this paper because the catalytic cycle, I'm again trying to mirror the spec paper. Having a catalytic cycle then will allow me to ask a range of questions such as, can I make them try and collect all the reactants and products in order to write the overall equation? Can I force them to try and work out the changes in oxidation state because there are redox reactions involved? Can I try to make them work out what is the type of reaction, whether it's redox, addition, substitution? Then could they work out what is the type of reactant? Is it a nucleophile, electrophile? And also comment on how useful this method is. So this particular method actually generates ammonia as well as pyro and another nitrogen heterocycle, which makes it potentially more useful than a method that generates only ammonia because this product is more functionalized. But one thing that we had to do when we finally set the paper was the diagram needed to change. So the issue of the diagram is there's some information for the on the paper that was in the text, and because this diagram was in along with the text in the whole paper, then it made sense. But when we give it to our students, we won't give them we cannot give the same diagram because some questions will be embedded in the text somewhere. So to make the diagram a bit more standalone and to make it a bit clearer and so that the information that students needed to answer questions was a bit clearer, the diagram had to be adapted. So this was the actual one that was used for exams. So the changes are highlighted in green. Most of the comparison is just to make it clear what are the reactants doing. It's a bit more obvious which ones are oxidation reduction, and the products are also a bit more obvious for them to start collecting reactants and products and for them to write a balance equation. Okay. The next article, this article I struggled a little bit more because it was a little bit harder to work out what exactly they've done. But what was promising about it was there was the summary in the teaser article, which helped a lot. Then some of the useful information will be things like reaction conditions. And there was also quite a bit of characterization data. They had boron 11 NMR and nitrogen 15 NMR. So the very early version of this question actually tested both, but later we took it out because I think it was a bit of a repeat. Yeah, again, looking at the diagram from the paper, this was the original diagram that I just cropped out from the paper itself. I'll show you the one we used for the exams first, and maybe talk a little bit about how was it different. The one in the paper had a bit more reactions because it told the story of what exactly the researchers did. But we weren't testing every single part, so we could take out certain parts of the diagram that were not used. So that would be the bits in the red color boxes. Those were removed in the exam question. And we also redid the diagrams so that it's a bit more understandable. So for example, all the substituents, the DIP, DUR, had to be written out for the students. I think one of the DIP was actually drawn out for them because at the end of the day we wanted to ask them some question about CH bond activation, and for that they needed to see what that ligand was so that they could see the CH where the new CH bond was. So depending on the question, we had to adapt the diagram to suit what we wanted to ask. And even the structure of the product was also redrawn. So the original product looked like this. It's all the dotted lines to show the resonance. And then later we redrew to this because there was one question about, I think, shielding effect and the impact on the resonance frequency, the chemical shift value for boron. And also because of that, we expanded on to add the question a little bit more since we've made them draw this really. Then there was also a question about how can you draw the resonance structures. So the question changed quite a bit along the way. Okay, I'm going to run through some considerations we had at betting. Then I will show you a few versions of the paper to highlight some of the maybe more major changes and what we were looking out for. Because in the survey, some of you asked how can you scope the paper to kind of assessment standard. So one of the issues which I don't think we resolved that well in hindsight was the length of the insert. Because it was a balance between giving the students sufficient background information for the context, then at the back of the mind, there was also an issue of whether they can finish reading in time. I think our eventual insert may have ended up a bit too long, so they took quite a while to work through. Changshan was mentioning that for the spec paper, the 2019 paper, they actually didn't change the abstract very much for the papers that they took the abstracts from. But for ours, we actually changed the abstracts quite significantly. Yeah. Then the maybe more usual question is about the flow of information in the insert, which comes first, which comes later, what needs to be there, what doesn't need to be there. Then flow of questions. The question order changed quite a bit as well in the process. The MO part was, okay, I will show you the example later, it will be a bit clearer. Then reformatting the data, including the diagrams, so that it's more readable to the students. And in doing so, it will help to modulate the difficulty level and make sure that this paper is still fair to students who are 18. Then we vet through the whole paper to try and make sure that it's balanced. So across the whole paper, there will be doable and more challenging questions. Then, okay, maybe I'll do the last one last. So, okay, this is the really very first version of the question. I've uploaded the Word document into the Google Drive, the same folder as all the 3 papers. So if you want to take a closer look or you prefer to open your own copy, it might be easier for you. So when was set out, I think the abstract followed the paper's abstract quite closely. This was cropped out diagram so that we have some placeholder. It's not nice, but it can be there for the time being. There was the catalytic cycle from the paper as it is. So one of the questions that I wanted to ask, because I really liked the diagram from the teaser paper, that one-page review, was this part here, part D. So I wanted them to be able to draw the diagram because I thought the diagram was very useful in explaining the donation of electrons into the antibonding orbital and the donation from electrons from a bonding orbital into the empty d orbital. In doing so, then that leads to the change in bond order. So that was to try and test something about MO. But there were certain complications because the question made sense to me because I've seen the article and I have seen the diagram. But during the vetting process, then there were some concerns about whether students will know what to draw. So the next part, in one of the next iterations, it looked like this. So we tried to give a bit more hints. We gave a diagram. So we drew part of it out for them so it's easier for them to see what is going on. And there were also hints in terms of where the axis would be so that they could draw it. But after arguing about axis for a while, it was still unsatisfactory. So the final version of the paper, we kind of gave up and just gave them the diagram. So instead of making them to draw the diagram, we asked them to interpret from this diagram to work out, okay, why would this interaction weaken the NN triple bond? And that's because the bond order is lowered. So the question became a bit more, or rather significantly more accessible or doable to the students. But the diagram itself is, at the end of the exam, we realized that the diagram itself may not be that easily interpreted by the students as well. So that's learning along the way. So one thing was the MO. This was one of the things that we changed. And I think the first draft, I set like 20 plus marks, just so that we have a lot of questions to cull from. How much marks? Yeah, the first draft was like 26 marks, some really, really high amount of marks. The SPQ first question was only supposed to be about 15 to 18. So I set extra marks so that we could figure out which one works better. There were some L's that were tested repeatedly. Okay. Then the questions for the second for abstract 2 was actually changed quite significantly. some issues was, I think, this question about carbon monoxide being analog for nitrogen. After some argument, we didn't think that the students would be able to understand what the question was trying to ask. It was taken out. Then, I think in terms of color changes, this one was supposed to be related to transition elements, but in the end, no, it was related to extent of conjugation. But because we had a later question that also tested this same concept, I think 2 times, so we took this out. There was an interesting paragraph in the actual article itself that talk about why things why they couldn't be easily separated. But because technically out, because we felt this wasn't test on the students. There was a bit on NMR absorption frequency, but this part was also modified subsequently. We look at the final paper. Right. If we look at the final paper, okay, the questions for abstract 2 changed quite a bit because the original questions were problematic for various reasons. Then Chongqing had to step in and to sort of re-look at the paper again to have another perspective on what are the other questions that we could ask. So given we have already shown them the reaction scheme, then we decided to ask about carbon-hydrogen bond activation on top of nitrogen triple bond activation. Then we still made them draw the orbital interaction, but only one set, and that's for boron. Then there were extra questions on how to draw resonance structures. So this is not strictly H3 syllabus, it's kind of H2-ish, but this diagram is actually not so easy to draw. Then, yeah. Okay, the last part, I think it was there in some form. I think we changed the wording, the exact wording itself. The idea is because we have 2 different contrasting methods, we wanted the students to compare and contrast 2 methods to make a comment on what was better, what are the strengths of each of the methods. So that's to do with the practice of science, understanding science and society. Okay, so which brings me back to this. The process was very iterative. We went through 3-4 drafts, I think even in the last week, just before the exams. So what I thought was useful was to have different perspectives. Having more than one person set or look at the SPQ was very, very helpful because I would come up with one set of questions and that would make sense to me. Then I wouldn't know whether it is reasonable and fair to the students or not. And having the additional perspective from the different vectors was very, very helpful. Okay. Then, okay, I'm kind of done narrating my process. Hopefully it's useful for people. And at worst, don't make the same, well, at least avoid some of the mistakes that we made. Then this is a summary of the takeaways that you responded you would like to have from this particular sharing session. So one thing that came out quite very strongly was about journal access. Chongqing shared some methods of how to start. Then what was it? Then the next one was thinking about which articles are related to the syllabus and or assessment objectives. My own take to this question is that SBQ can be quite broad. I don't think there's necessarily a fixed type of question that we need to hit at. And yeah. Then suitable articles, this one partly may depend on the sector as well to think of which data type you like to work with and what kind of data is more natural for you to start thinking of questions from. And there was one interesting comment, but I didn't quite really understand what it was. The part about allowing the question to fit in naturally to the paper, I'm not quite sure what the person meant. So then some of us would like some example questions as well as thinking about how do we pitch the questions to the appropriate difficulty level. at this point in time, the correct standard papers, we only have two examples, which is the specimen paper and the 2019 paper. The other thing that could be useful is at the first cut to look around to see the different schools' prelim paper from last year and to make your own assessment, what kind of question types you think are fair, which kind of questions you think are a bit difficult, which kind of questions you think are meaningful to set and to provide for the students. And I think at this point that could be the best that we can do. Yeah. And that's that for me. Maybe I can show maybe I'll show this list of takeaways, and if anyone would like to chime in on specific aspects or questions, please do.
Yeah, do you all have any questions at this stage that you have for us to discuss? Oh, I think there's a question from Gerard. I think he asked about. Sorry?
No. My concern is that would be too much text for the students to read through.
Yeah.
If you have two SPQs, does it mean that you have like 4 abstracts?
maybe 2 abstracts lah. I think. If not, I will maybe use the last 5 minutes or so, right? To just say something regarding what I wanted to say just now, which we didn't have time to lah. Yep. Okay. So just give me a while. Yeah, hi. Oh, I saw the comment that it is possible to set to of course my idea, my comment will be at the end of the day, right, is a balance between depth and breadth lah. Yeah. So if you want to have 2 stimulus based, then something else has to go lah, because the exam is only kept in 2.5 hours. Yeah. So it depends on the kind of experience you want to give to your students. Okay. Then another point I thought I can make a mention, right, is that whenever you guys set a stimulus based question, right, let's say it's for daily work, maybe not daily work, but something related to formative assessment, right? Before or after lah, okay, maybe before you give to your students, if you want a second pair of eyes to take a look and bounce ideas, right? Yeah, I think we will always be happy to take a look as well. Yeah, especially I think Shuang Ning and I will not say no to you. Of course, whether you think we are the best person, that's another story lah. But I'm just saying that I will always be, or we will always be very happy to take a look at those questions lah, because I don't know lah, as in looking at them just make me feel that the day is worth living to some extent. Yeah. Okay. In fact, actually on my end, right, on our end, but it's just within the computer screen. We have actually, or rather, I on my own, right, I've actually modified one or two of the JC's stimulus based question last year for use in our own tutorial. Modify to make it maybe it's a bit okay, it's a bit disrespectful, but if you want to put it explicitly, right, modify to make it look a bit better lah. And so every time I've done that, then I will send to Shuang Ning and say, hey, you know, like this is what I've done, what do you think? You know, like if you always have someone trusted, you can to bounce ideas, right, you can always just send. Of course, it's at your own comfort level lah. Okay, yeah, I mean, before I speak too much nonsense, right, I just go straight into this first. Just give me the 5 minutes, and then after I'm
Maybe I
done.
just add on for a bit. I think the exchange of ideas is very, very helpful to just have a different perspective, to see what someone else thinks of the question. And during the exchange, you also get to see a little bit more variety in terms of question, because it's actually not very realistic for all of us to like have practice setting 10 times. Then we just don't have that kind of time. It's not possible. We won't do it. But having seen someone else's work or another question, it gives you a sense of, for me, I think the value is, it gives me a sense of what I think works for a question and what I think can be improved. So as I go through a question, I'll be like, oh, this is quite fun. I like this kind of question type. Then there'll be somewhere where I'll be like, this question asked something like that I don't like. Yeah. So it just it's a medium for me to bounce my ideas off and let me have a clearer idea of what works and what doesn't work. I may not have the correct answer, but at least I have some more sense about, or some more examples, some more exemplars to have a sense of what might be useful and what might not be, and what to take note of the next time if I'm doing this.
Okay, my final bit is also a bit of a suggestions as well, right? Is that even in the H2 journey, right? If you are able to incorporate in your 2 years of H2 curriculum, right, some form of this kind of like database kind of questions for your students, right, I think it will be very helpful to get your pool of teachers to start to think of ideas and then come together to have some interesting ideas in order to set a good stimulus-based question for H3 lah. Okay, so this was the segment I call it our journey. In Hwa Chong, it's more of like, well, I mean, it started off I think in 2012 when I was back then I was involved in one of the special program in the schools, and then along the way sometimes we need to stretch the students a little bit, so I need to think of some ideas to incorporate into the curriculum, and this is one of the idea I call it literature appreciation, but we don't give the students the whole literature, of course, but we give them snippets of it. Yeah, so if you look at this interesting just a snapshot of the abstract it's like how many lithium ions can be inserted into the fuel C6 aromatic system, then yeah, I mean, the article has some interesting points, and then later on it can be framed into a question like this lah. I mean, I hope you can see the screen. Yeah, so this is it will be framed into something like something like this. I thought it's really it's a good starting point to get the teachers to start to do something. It doesn't need to be like, oh, I'm supposed to set stimulus based and that's it, you are left on your own lah. It's good to cross train the pool of teachers that you have in many areas, so that everyone is used to doing something, and then, or you can have a pair working on one question. I think that will be very, very helpful lah. Yeah, so and because I think for my case, we started the journey way earlier before the stimulus based question comes out, right? So that's why along the way it's kind of like a little bit easier to come up with some ideas, and then maybe to share with people that, okay, maybe we can go in this direction, that direction. Yeah, okay. So and for our case, if you want me to put it explicitly, for our H3 curriculum, right, we actually have 3 assessment points, but it's no longer 3 lah. Okay, in the normal years. Okay, so the one sometime in March, it's now called the individual and collaborative task, and then the one sometime in May we have Viva, and then a major assessment is actually called lecture test. Okay, there's no longer 1 and 2, it's just lecture test, and then we have prelim. Yeah, so if you have a team of 3 or 4 teachers doing H3, you can just split out the load, 2 for prelim, 1 for lecture test, and 1 for the collaborative task. Yeah, and then everyone gets an experience of doing that. Okay, and back in 2017 or even 2016, yeah, so we have already started work on this, and so these are some of the questions that we came up with in order to really get the engine running lah. It's a bit old chemistry, very old chemistry, but it's related and it's very useful for even the current group of students. That's what I can share with you at this stage. Okay, yeah, and then for last year, sorry, 2 years ago, in fact, for our final batch of Pharm Chem students, right, we started giving them stimulus-based questions. So we did transition metals, chemistry for them. Okay, and in 2019, 2020, last year, I actually went to search for some ideas, and then I realized I took note of this nucleophilic substitution ideas, okay, from this Professor Tan in NTU, used to be from NUS. I thought that it can be asked in a interesting way, like for example, he came out with this SN2X mechanism, okay, and then the other paper I read has this stereoselective SN1, so I thought of having the two together, okay, but eventually for 2019, right, we only did it for stereoselective SN1 because it's just too much information for the students. And then for this year, my other colleague Gao Hong, right, actually set a question on SN2X. So as you can see lah, although we only search for once, but the data can be used for 2 years or even 3 years. Yeah, so sometimes if you just do a very deep dive and search, sometimes you might have enough information for you to last you for a while. Yeah, so these are some of the things I thought I can share with you, and earlier on, yeah lah, because we don't want to keep the time, we don't want to overrun, that's why I passed the mic over to Shuang Ning first. Okay, at this stage, do you have any questions? I mean, we are pretty much done. Yeah, but we'll be happy to take any question for that 5 minutes if you have, so that everyone can listen.